In this video, we're going to discuss how to write numbers in scientific notation. So in sciences, we often deal with numbers or measurements that are very, very large or very, very small, such as the diameter of the sun, or in chemistry, we may discuss the diameter of an atom. Writing these numbers can be very tricky and time-consuming, not to mention that sometimes we can't fit these numbers into our calculator, where we can only hold maybe 8 digits in our calculator. So we need a more compact way of writing big and small numbers. That more compact way is what we call scientific notation. The general formula for a number in scientific notation is n, where n is some number at least 1, but less than 10, so it could be anything from 1 up to 9.999, times 10 raised to some power, m, where that m could be a positive or negative exponent. So given this general formula, let's look at some examples and see if we can understand how to apply this formula. So let's look at how to write very big numbers in scientific notation. Say we were talking about the distance from the Earth to the Moon, 380 kilometers. How would we write this number in scientific notation? Well, the first thing we need to do is move the decimal place from right to left until we get to an integer that's at least 1 but less than 10. So we need to move the decimal point, which is of course understood to be right here at the end. We need to move it from right to left until we get between the first and second non-zero number. So here we would move the decimal here to give us 3.8. That's a number at least 1 but less than 10. Next, count how many places you had to move the decimal place to get there. So we had to move the decimal place 1, 2, or the decimal point 1, 2, 3, 4, 5 spaces. And we want to include all significant figures in scientific notation. We'll talk more about significant figures a little bit later, but for now, let's include all the non-zero numbers. So we moved it 5 spaces to get to the 3.8. So we write our scientific notation would be 3.8 times 10 to the 5th. Since we moved it 5 spaces, it would be times 10 to the 5th. And we want to include units. Our units are given as kilometers. Include those in scientific notation. So 3.8 times 10 to the 5th is the same as writing 380,000. And that's because what we're saying here is that we take 3.8 and multiply it times 10 times 10 times 10 times 10 times 10, 5 times. If you take 3.8 and multiply it times 10 5 times, you get 380,000. So these are equivalent. Let's look at one more large number. Okay. Here we have the approximate mass of the Earth in kilograms. Write this in scientific notation. So we need to move our decimal point from right to left until we get to a number between at least 1 but less than 10. So that would be 6, and put the decimal right after the 6. Now we need to count how many spaces we've moved that decimal. I'm going to count by 3's to save time here. We've moved the decimal point 3, 6, 9, 12, 15, 18, 21, 24 spaces to get there. And we include all our non-zero numbers. And so this number, since we moved it 24 spaces, we would write 6 times 10 to the 24th kilograms. 6 times 10 to the 24th kilograms, again, is much easier to write than this big number, also much easier to put in our calculator. So that's saying that we take 6 times 10 24 times, or 6 times 1 with 24 zeros after it. If we do that, again, we come back to our original number. So let me have you practice a couple. Pause the video and write these 3 numbers in scientific notation. Okay. So for the first one, we want to move it from right to left till we get 4.56, and we moved it 5 spaces, so 4.56 times 10 to the 5th. Here, we need to move it from right to left. We move it 10 spaces until we get to 3.4. So we have 3.4 times 10 to the 10th. And this one's a little tricky. The decimal is already where it needs to be, so we don't move it. In that case, if you come across one like that, we would say 5.66 times 10 to the 0, because we're not moving the decimal point any spaces. Now let's look at how to convert small numbers, numbers less than 1, into scientific notation. Let's say we had a wavelength of light, and this was the wavelength. Convert this into scientific notation. We follow very similar rules as we did for the big numbers, but we need to move the decimal point instead of right to left, we need to move it left to right in order to get a number that is at least 1 but less than 10. So we move it from left to right until we get 7 with the decimal after. So that would give us 7. So how many spaces did we move it? Well, we moved it 1, 2, 3, 4, 5, 6, 7 spaces. So that would give us, since we moved it 7 spaces, our number would be 7 times 10 to the minus 7 nanometers. Okay, include your units. Since we moved it from left to right, we have a negative exponent indicating that this number is less than 1. So 7 times 10 to the minus 7 is equivalent to this number because it's another way of saying 7 times 0.1, 0.1, 0.1, 0.1, 0.1, 7 times. So the negative exponent means we're multiplying not by 10, but by 0.1 or 1/10. And so if we do that, punch that in your calculator, you come back to the original number. So again, it's a more compact way of writing these very small or very large numbers. So again, pause the video and see if you can write these two numbers in scientific notation. So here, we move the decimal between the 5 and the 0. We end up with, we don't count any of our leading zeros, but we've moved it 1, 2, 3, 4, 5 from left to right. So we have 5.0 times 10 to the minus 5. And here, to get 7.094, we moved it from left to right 10 spaces. So you can see the answer here. And finally, let's look at how to do the reverse. Often you're going to be given numbers in scientific notation and asked to write them in standard or decimal notation. So let's say you're given a number like this that's in scientific notation, and you needed to convert that into standard notation. How would we do that? Well, we basically do the reverse. I noticed that this is a positive exponent, so to get here, I moved it from right to left. So to get back into my standard notation, I'm going to move it from left to right 2 spaces. So if I move it from left to right 2 spaces, 5.2 times 10 to the second is the same if we move it 1, 2 as 452. Now another way to write that, if that doesn't, that's not your preferred way, an alternate method would just be to take 4.52 and multiply it times 10 to the second. 10 to the second is 100, one with 2 zeros. So if we take 4.52 and multiply it times 10 times 10, or times 100, we again get 452. Let's look at one other one here. 8.5 times 10 to the fourth. Write this in standard notation. We move the decimal from left to right 4 spaces, and we get 85,000. Or, if you prefer, you could take 8.5 and multiply it times 10 4 times. If you take 10 4 times, you get 10,000. So 8.5 times 10,000 is 85,000. And finally, let's look at how to convert very small numbers, those with negative exponents, from scientific into standard notation. So if we had 4.5 times 4.52 times 10 to the minus 1, well, to get into scientific notation, we moved it from left to right, if you recall. So here we're going to move it from right to left 1 space. If we move it from left to right, or excuse me, from right to left, we get 0.452. Alternately, of course, you could take 4.52 and multiply it times 0.1 and get the same answer. Okay. And one final example here, 6.32 times 10 to the minus 5. We want to move the decimal place from right to left 5 spaces, so we're going to have to put some zeros out there. So 6.32, we moved it 1, 2, 3, 4, 5 from right to left, and we get this answer. Alternately, again, you could take 6.32 and multiply it times 0.1 5 times. And if you multiply 6.32 times 0.1 5 times, you again get the same answer here. So be sure you can go from scientific to standard notation or vice versa. Okay? Practice a couple of problems here. Pause the video and give this a try. Okay, so for this one, we need to move it from left to right. We have a positive exponent, so we know our number is going to be bigger than 1. So we're going to move it from 6, 1, 2, 3, 4 spaces to give us 60,700. Now here we have a negative exponent, so we're going to move to get into standard notation from right to left. We started here, we moved it 1, 2, 3, 4, 5. Or again, alternately, you could multiply 3.400 times 0.1 5 times. So be sure that you can write numbers in from standard into scientific notation or vice versa. This is a very, very critical skill that we use all throughout chemistry and other sciences.